Alright, AP friends, for the last part of our section 5.5 videos and notes today, I just want to go over two more examples. One that's going to use trig, and one that's going to be using definite integral, which means we actually have numbers. So this is sort of considered maybe extra problem number one, if you want to call it that. Alright, can you guys find for me the integral of the cosine of 4x dx? All right, with trig, a lot of times as a hint, the inner function is usually what is inside of the trig, the cosine of what. It's usually very complicated because sometimes it's not just x or theta, it's a 4x or an x squared or something on the inside. This happens a lot with your e functions. A lot of times when you have e to the x, usually the u, whatever is inside the exponent. For example, if you had e to the x squared plus 1, the inner function would probably be the x squared plus 1. So similarly, when you're in trig mode, usually the inner function, is what's inside of the trig expression. So here, I would say 4x is our inner function. So let's call that u. U equals 4x. All right, let's do the same steps before. Hopefully this is getting better now, folks. Okay, so there we go. Now we're ready to just substitute everything back in. And here we go. This becomes the integral of the cosine of u, because u is 4x, times dx, and dx is 1/4 of du. Looks like all the x's have disappeared, which is great. And again, I can take that 1/4 and toss it in the front. And this becomes 1/4 the integral of cosine of u du. And we're set to go. How about the antiderivative of cosine? It is regular positive sine. Don't forget the plus c. And then again, the last step, let's just plug the x expression in that we used for u. How about 1/4 the sine of 4x plus c? Final answer. I do want to double check this one, and I'm going to take the derivative just to see if it really does work, because it's trig, so it makes me a little bit nervous. Here we go. Let's take the derivative. That would be 1/4 stays on the outside. Using chain, the 4x is now my u on the inside. This would be cosine of 4x times the chain, which would be times the inner, which is 4. Plus c just goes away. Do you see what happens here? There you go, and you're left with. So it works, guys. So a lot of times the inner function is going to be what's inside the trig. Okay, let's try one that's going to be a definite. Remember, definite integrals happen when you have an actual number on the upper and lower limit of your integral, which means you're actually going to plug in numbers. But with U-substitution, it's going to be a little bit complicated. Let me walk you through a really good one. Let's do the integral from 0 to 4, that's definite now, of x times the square root of 16 minus x squared dx. Again, we want to take the antiderivative here, friends, but it's not a typical one. I actually, believe it or not, I saw this and I almost thought, ooh, this is the one we have to do like a semicircle, right, and do that. But the difference between this one and the semicircle is this little friend right here. The semicircle ones, where we have to find the area of the semicircle, doesn't have an x included. It would just be the root 16 minus x squared. But here, it's not a semicircle because we have the x here. So we got to try to take the antiderivative the normal way. Well, I see an inner function right inside the square root is here. So let's start that guy. U equals 16 minus x squared. All right, derivative of this one would be a negative 2x. Keep going. And get basically, this is my dx in terms of du. All right, let's plug everything in. Here we go. This becomes the integral of x is just x for now. The square root of, well, that's our u, because that's 16 minus x squared, and dx became negative du over 2x. But I'm missing something really, really important. Before I get rid of the x's here, I'm missing something. Do you see what I didn't write yet? It's these numbers, right? I didn't write these. And the reason is, they're not 0 and 4 anymore. And the reason is, way back when over here, when it was 0 and 4, these were x values. as x goes from 0 to x goes to 4. But now we're switching into U mode. These are supposed to be U numbers. So now we have to go back and try to recalculate what the U numbers are going to be. But just so we can see it a little bit easier, let's go ahead and just simplify inside the integral first. All right, the x is here, and the x here cancels. That 2 is going to go on the outside as a 1/2, and actually that negative can go on the outside as a negative. So right now, let's just clean this up first. Negative on the outside, the 2 on the denominator becomes a 1/2 on the outside, the integral of the square root of u du. Okay, that looks a little bit cleaner. But now let's figure out what these limits on the top and bottom of my integral are. Because we're in u now, we're not in x anymore. X was going from 0 to 4. But we need to figure out what is that in terms of u. Well, why don't we come all the way back here, ready? All the way back here. If we use our U-substitution expression, we can go back and figure out when x was 0, what is your corresponding u value? Can you plug x equals 0 into your u expression? I would get 16. And can we plug 4 into your u expression? When x is 4, I get u equals 0. So now I'm going to plug these back in. We did have a 0 on the bottom, so the 0 on the bottom turns into 16. We had a 4 up on top for x. That corresponds to u of 0. This is a really important step that we took here, folks, that you do have to change the limits on your integral because you're in terms of a u, a different letter than you were when you're in terms of x's. So please don't forget. Okay, so let's keep going. Now, inside the integral, it's a very simple expression, so this isn't too bad. Negative 1/2, the integral from 16 to 0 of u to the 1/2 square root of u du. This is pretty easy to integrate. This becomes negative 1/2 on the outside. U to the 1/2 turns into 2/3 u to the 3/2. Notice I'm not going to put plus c on the outside. Why is that? Because he's a definite integral. We don't have to write plus c on the outside. But we do have to evaluate this guy from 16 up to 0. Now, here's the interesting thing. First, let me go ahead and simplify these fractions that we have here, friends. This becomes negative 1/3 u to the 3/2. I'm going to evaluate from 16 to 0 from our integral. Now, what we did before when this was an indefinite integral is we would change this back into x's because our final answer needed to be matching the variable that you started with. We started with x's, we need to end with x's. But not here. Remember, we put all this hard work into changing these numbers into u's. So if it's okay with you, let's not change back to x's. You are good to go. If these are in terms of u, and we've got u here, we just plug them in right now. Don't go off into x mode. We don't have to. Save a step. Let's try it. All right, the negative 1/3, he's a constant, so I'm just going to let him sit out for a little bit while I plug everything in. Okay, this becomes 0, plug in the top number first, minus, plug in the bottom number next. And that's what that would look like. This is in terms of u, so we should get the same value we would get as if we went back to x's and went back into x goes from 0 to 4. But I think this saves a step, so it's a little bit easier. All right, I have a feeling 0 to the 3/2 is just 0. That's pretty, but can you do this without a calculator? Gonna need to know how to. My final answer, folks, is 64/3. He's a definite integral, so I should end with a definite, meaning numerical answer. So again, to go back up a little bit, the most important step here is when you change your integral into u's, make sure you change your u values on the integral. When you take the antiderivative, we don't need the c value, and we don't have to go back into x mode anymore. It's okay, because we're in u's and you have u values. So this works out really well. That concludes this video and all the notes. Now we're going to get a chance to practice and play. Good job, friends.